So what are you guys doing here? Didn't you read the abstract? It says, don't come to this talk, and yet I see many people. Well, you could have gone to really interesting other talks, but you chose this one. OK, so I'll get started anyway. So this is the title. I put the emoji in the title just to try to hack the conference as well. But JavaZone have actually been pretty good with this. They render the emoji pretty well. At another conference, I got emails with question marks instead. So a little bit about me. This is a picture of me in a dress suit wearing a sombrero, which is more or less what you can expect from this talk as well. I work at Codestar. We're a consultancy in the Netherlands. We do mainly Scala and also front-end development. So I'm this guy who does Scala for his day job and Java in his free time. And I'm going to tell you a little bit about that. You can also follow me on Twitter if you like. Some of you may know me from a tool that I created called Verifier. It's a tool that you can use to test if your equals method follows the contract that's defined in objects equals Java doc. So if it's transitive and reflexive and all that. And basically, all you have to do to test this is this one-liner, or actually two-liner. So you can imagine to make that work, lots of dirty tricks are happening in the background. And while you are thinking up these dirty tricks and debugging them, you run into certain things. Some accidents, maybe. And that's what this talk is going to be about. It's about these accidents that I discovered while doing equals verifier and also while talking with other people about them. And how you can use them as weapons against your coworkers. Because who doesn't want to mess with his coworkers, right? I guess you all do. That's why you're here. So there are a couple of categories of things that you can abuse to mess with your coworkers. And I'm going to discuss all 4 of these in the talk. And for every hack that I'm presenting, I'm giving it a rating on a scale of 1 to 3 emoji, how bad this thing really is, how badly you can mess things up. So let's get started with the first category, the language features. OK, so true Lambda. As you all know, since Java 8 has been released, we have lambdas. But a lambda wouldn't really be a lambda if it wasn't actually called lambda, right? And this is something that just works in Java. Java is OK with this. As you can see, the program just runs smoothly. So you can use a lot of Unicode symbols in your Java identifiers. Also, maybe you've noticed, I've been using Java 11 in this code. You can see that by the usage of the word var here. I'm doing this because I want to show you that all of the hacks that I'm presenting tonight, they are future-proof. They all work on the Java 11 early access, the latest build. And that's going to be long-term support. So for many years to come, you can use these hacks and annoy your coworkers. And while I'm at it, there are some other things that you can use to annoy your coworkers if they come sit at your desk. As you can see, I'm using a weird color scheme. I'm using the Vim plugin, which is also a lot of fun when people start to try and pair program with you. And the Nyan cat, well, it went away quickly, but you'll see it some more during this talk. So I was talking about Unicode symbols in your code. And you can, of course, take that a step further. by doing this. Unfortunately, IntelliJ doesn't render this as nicely as some other renderers do. So it's not as pretty to look at in IntelliJ, but it does work, as you can see. And it even works with reflection. I can take my identifier name and put it in a string. Obviously, you have to copy-paste it, but because no sane person is going to type it. But it works. So Unicode symbols, using them in your code. It's fun. It's hard to type. It can be hard to read. But not much else is going on. So I'm giving it only one emoji. Moving on to the next one, though. I have a little program here. There's a comment, and then there's an assert equals. And it asserts that true and false are the same thing. So who thinks this test will fail? Please raise your hands. I see one hand in the back, and one more. Who thinks it will pass? I see some more hands. Who is uncertain? Who is afraid to raise their hands? Still haven't seen everybody. So let's try it out. This test passes. And why do you think that should be? Well, it certainly can't have anything to do with this comment over here, right? I mean, it says so. There's nothing to see here. So what could it be? Well, of course, you're not that stupid. There's a little Unicode escape sequence here. And probably all of you who did your Sun certified Java programmer, or later Oracle certified Java programmer, or whatever they call it now, you have learned that Unicode escape sequences like these, they get parsed by the Java parser before it's actually interpreted. So this sequence here is a new line, and the Java compiler actually sees a new line here, and the if return true, or the if true return, is actually executed. I had to put the if true before, because IntelliJ actually saw through my little trick, and it will flag dead code coming up if I didn't add this in. Oh. So if I remove the comment, the test fails as it should be. So if you ever have a flaky test, this is how you can fix it. Really easy. Nobody will notice. So this is Java, and some time ago Scala came along. I've been using it a lot, and Scala claims, at least people who use Scala, they often claim that it's a lot better than Java. So I figured, let's see if it actually is better. See if it also suffers from this little trick. So what do you think? Is the second print line going to execute? Who thinks it's going to execute? Nobody? OK, who thinks it's not going to execute? Ah, there's some more hands over there. But still a lot of people who aren't sure. It's not going to execute. Scala has the same problem that Java does. So, but after Scala, then Kotlin came along, of course. And what do you think about Kotlin? Is it going to have the same problem? Is the second print line going to execute? Who thinks it is? I see a couple of hands. Who thinks it won't? Again, a couple of hands, but slightly more. I'm sorry, this in Kotlin they actually fixed it. So, you have to know in which language you are messing with your coworkers. I'm going to give this 2 emoji because this is pretty bad, right? You can break unit tests. You can make flaky tests not execute. Nobody will notice. That's pretty bad. I'm not giving it 3 emoji yet because some fun stuff is coming up still, but it's still pretty bad. OK, so if we have these Unicode escape sequences, can we take this a step further? I have here a little program. It contains a string with another little program inside. And what it does is it simply converts this code into Unicode escape sequences. And this is the output. OK, so nothing really too exciting here. I'm going to copy this and go to the command line. And now I have a little file that contains the same Unicode escape sequences, right? So when I compile this class, Java-C doesn't care. It just executes. It doesn't raise an error or anything. And I now have a class file as well. So can I execute that? Of course. Hello, Oslo. So if you ever want to include some evil backdoor into your code, this is a perfect way to hide it. Because the Java compiler just compiles it. And Maven doesn't care either. Only IntelliJ notices. So you have to be careful with that. But I'm sure you can figure out a way to hide it from IntelliJ while still including it in your build. So this one is a little bit harder to type and obviously to read. But yeah, you can hide some really nasty things in there, so I'm going to give it 2 emoji as well. Speaking of emoji, we can include lots of Unicode symbols in our Java identifiers. Unfortunately, we cannot do that with actual emoji in Java. But we can do it in Scala, which leads to some pretty fun code, right? And this just prints hello Oslo again. So if you want to obfuscate your Scala code, this is a good way to do that. I'm going to give it only 1 emoji, but it's very festive looking, so I'm giving it the party emoji. OK, so the next thing, a completely different thing, is hash codes. I have here a little program that declares 2 strings and then prints them out, and then prints their hash codes. And there's this function there, string with same hash code. And it actually generates a string with the exact same hash code that the other one does. I can prove that by running it. I'm not going to explain the code, but as you can see, the 2 strings are very different, but they have the same hash code. This is a pretty neat trick. But can you do anything with it? Not really. If you have a junior coworker who insists on using hash codes as a key in a collection or something like that, you can use this to deter them. But other than that, there aren't many applications for it. Except about 1.5 years ago, I saw this in the Dutch news. It was an article about how during the national elections, no, I think it was the local elections, actually, they used hash codes. They took the ballots, calculated a hash code over them, and used that to verify if the ballot was actually cast properly. And some hackers found out a way to generate a ballot with the same hash code, but with a different vote on it. So this caused a little fire in the Dutch news for a couple of days, and then it went away because nobody really understands it. But you can use this trick to mess with the election. So I hope there's not any Russians in the audience tonight. If there are, I'm sorry I offended you. I'm sorry. So that's it about hash codes and the Java language features. Let's talk about reflection a little bit. I created a little library called Reflector. It's basically just a little helper functions for me to use in the code that I'm going to show you next. The only thing that it does is it wraps the existing calls to Java's reflection API and adds a call to set accessible true so that I can more easily deal with that. Other than that, this doesn't really do anything. But I wanted to show you so that you can see that there's nothing magic going on in here. So what can we do with this? I have a little class over here, and it does a little reflection trick, and then it loops over the integers from 0 until 10 and prints them out. So who of you thinks it will print 0 until 9? You've been learning. That's good. That's good. Nobody raised their hands. Who of you thinks that an exception will be thrown? Nobody? Well, you're all correct, or just too lazy to raise your hands. Because the code goes into an infinite loop. I'm just going to break it off here. And this happens because in Java, the boxed integers are actually cached until, I think, 128 or something. They are all cached. So whenever the Java compiler wants to box an integer, say the number 4, it goes into the cache, and then it takes the value out of the cache. But what we did here in the first line, we took the number 5 from the cache, and we got an integer object, and then using reflection, we changed the value of that object, of the 5 object, to 4. So that means that in the loop, whenever it gets to 4, it adds 1, it ends up with 5, then it takes 5 out of the cache, which is now 4. So it has 4, and then it adds 1, ends up with 5, which is now 4, etc., etc., etc. So who thinks this was a good idea? Oh, way too many hands, guys. Must be late. You want to go to the party, I guess. Actually, this was pretty evil. I think most people agree with that. And this is because we expect a thing to be immutable, and then suddenly it isn't. And that can really mess with your code. It's actually really fun to change, to do this trick in a unit test, because in a unit test we often use magic numbers. And this way you can mess up the magic numbers, and then suddenly tests will start breaking. This goes for the whole JVM, so when this code executes, all the tests that come after break in the same way. So this is messing with immutability, where you expect immutability, but something isn't. This is something that we Java developers know very well, because calendars and arrays and also most of the collections API are mutable in the same way. But we know this, so we use defensive copying and all kinds of other tricks. And nobody really likes it, but we do it anyway, right? And with JPA entities, we seemingly just don't care if something ends up in the database that we didn't expect. Every JPA entity is mutable. OK, so I just told you how you can mess up an entire test suite this way if lots of magic numbers are used. So I'm giving this tree emoji. But there's more. So this class contains 2 string variables. I print them out just to show you that nothing weird is going on before I assign them. Then I do a little reflection trick. And I will print out one of them, and then also the string hello world. So you will probably see from the code that the world variable will now contain the string hello Oslo. But what will the last line in this program do? Will it print hello world? Can I see some hands? Yeah, I see a couple over there. One over there. OK, you've not been paying a lot of attention, have you? This actually prints hello Oslo twice. And that's because string literals in Java class files are interned. And that means that they occur only once. And every time they are used again in the Java code, the same constant in the class file is used. So if you mess with that constant, you do it for the whole program, or at least for the whole class file. So be aware of that. If you use lots of magic strings in your test code, you can use that again to mess up a bunch of unit tests. And maybe you already saw it in the output. I got a warning. It's an illegal reflective access error. And you get that when you do reflection on a class that's defined in a module that is not open for reflection. In this case, it's the Java base module. And this was introduced in Java 9 with the module system. And a lot of people thought, with Java 9, reflection suddenly won't work anymore. And certainly for my talk, this was bad news. Fortunately, there's a way around this. And as I said, it still works on Java 11, so it will work at least for another 3 years or so. You can add this to your command line. And I'm just going to insert it here. And the error is gone. So if you manage to put that in your Maven build file somewhere, then you're good to go, right? Just do it on a Friday afternoon when everybody's out drinking beer. So interning, it's a fun way to mess up unit tests. But because the scope is a little smaller, you can only do it for the same class file, not the whole test suite. I'm docking one emoji from the score. The next one is something that has a check style warning. And check style warnings can be flagged in your IDE or in your build or on a Sonar server somewhere in your continuous integration system. But they can be pretty annoying. As you can see, this is a check style warning about not following the naming conventions. That's pretty easy to fix, but sometimes you have check style warnings that are not so easy. For example, cyclomatic complexity issues. Those are kind of annoying to fix, right? Or if you have a class that has too many parameters. If only there were some way around this. Turns out there is. I have a little program again, which contains a string that has the same program that I showed you just now. And in the main method, you will see that it actually gets compiled to a new class file, and then it gets loaded by a new class loader, and then it's invoked through reflection. And if you do that, as you can see, it just runs, and there's no check style warning. Unfortunately, to make that work, you have to type quite a lot of code. So you just put that in a library somewhere. By the way, this is all on GitHub. I will give you the link after the talk. So you can download this and try it for yourself. This code is not production ready, though, because the URL class loader is something that you have to close after you're done using it. Also, you may want to use the compilation task class to get useful error messages. It contains lots of interesting things like the line and the column in which the exception occurred, and a nice message as well. Also, there are some exceptions that can be thrown. that you should probably catch. But we're not here to write nice code, right? We're just here to mess with your coworkers. So, Another cool thing that they introduced in Java 9 is the multi-release jar file. Does everybody know what that does? I see a couple of hands. Basically, it means that you can include a class in your code depending on which JVM it is run. So you have your Java 8 code that lives in the main part of your jar file. And then you can have a specific piece of code that only gets executed, that gets replaced when you're running on Java 9 or 10 or 11. And the Java runtime will choose the correct version of the file. But if you're still using a Java 8 code base, how are you going to do calls to Java 9, right? This was actually something that I ran into with equals verifier, because I wanted to keep supporting Java 7. So all of the code and the build should remain on Java 7. But there were some corner cases that I wanted to test in my unit tests that only occur on Java 8. For example, what happens if you include a Lambda in your class? And I used the same trick that I just showed you with the compiler to go around that in my own code base. So what I did is I took a little class. It contains a Lambda. I put it in a string, and then if Java 8 was available, then I would on the fly compile the thing and run the test. And this has worked in production for many years. So it can be done. You can do this. Use your imagination in how you want to apply this. You can hide some nasty stuff in there this way as well. OK, so the next subject is annotations. Who likes annotations? Not so many people. So many of you will have heard about Lombok. Lombok is a tool that you can use to basically change Java into something it's not. It will change your code. It will generate some bytecode that does something else than is actually described in the class file that you just wrote. And it does that all at compile time. So that does mean that if you make a mistake, it will be caught at compile time and your build will fail. So what is worse than that? Doing the same thing at runtime, right? Fortunately, there are libraries to do that too. They're called Spring and Hibernate. Many people use them. You can mess up your stuff with those things for sure. But since everybody does that at work anyway, I'm just going to skip over that for now and move on to the final subject, which is external libraries. And I've chosen some libraries that are likely to be used in your project already. You may not know that they are used in your project, but they probably are. So who of you has heard of Obgenesis? A couple of people. It's a library that can instantiate an object without calling the constructor first. That's the only thing it does, but it does it really well. So let's give you a little example. So I have a program. It contains a class. The constructor in that class will throw an exception. But the toString method doesn't. And I want to call that toString method. I can easily use Obgenesis to do this. As you can see, it's pretty easy. You just instantiate an object of the Obgenesis class and then ask it to create a new instance. After that, you can just use it as if it were a regular class. And as you can see, it runs. There's no exception. It just works. There are many legitimate use cases for this, actually. most commonly, it's used in mocking frameworks. So if you want to mock a class because it's too difficult to instantiate it, you let the mocking framework instantiate it for you, and under the hood, it probably uses Obgenesis. So this example is just to show you what it does. It's not very interesting yet, but let's change that. So many people of you have probably read Effective Java. And in Effective Java, the book by Joshua Block, he says that if you want to create a singleton, the best way to do that is using an enum, because the JVM guarantees that only one instance can ever exist of an enum instance. And it even uses the word ironclad guarantee. So earlier this year, or last year maybe it even was, the third edition came out. And I'd already read the second edition, but I bought the third edition because I wanted to know if the quote was still there. And it was. So obviously, I wouldn't be telling you all this if I wasn't going to do anything with it. So in this program, I have an enum. It's a singleton, or it should be a singleton. And the first thing the program does is it copies the singleton. And then it does a couple of print lines to prove to you that it has actually done so. And if you run it, well, you get the illegal access warning again, of course. I'm not going to disable it this time. But as you can see, there are now two objects of that singleton type, and they are not the same. And how does that work? It's actually pretty easy. We take an Obgenesis instance again. We ask it to create a new instance of our singleton type. And an enum has two fields under the cover. It has a value or an ordinal field, which is the sequence number where it occurs in the enum declaration. It starts with 0 and then it adds up. And obviously it has a name. So if I copy those two over, then I have a new instance with the correct name and the correct ordinal, and you're good to go. You now have two instances of the same enum of your singleton. So yeah, I actually looked it up in the Java language specification as well, and it uses more or less the same words. So I'm surprised that it's actually so easy to prove this wrong. Obviously, you can do a lot of nasty things with this. If your unit tests or if your production code assumes that there's only one instance running of that thing, strange things may happen. But let's take it another step further. And for that, I have to explain to you that in France, maybe other parts of the world as well, you can buy tarot cards. And these tarot cards are not used for telling the future. They are used to play games, just like regular playing cards. The difference is that they contain an extra suit, the trump cards. But when we are programming with suits of playing cards, usually we only have the 4, the well-known 4. So what I wanted to do is add another one to an existing enum. And as you can see in this program, I have such an enum. I iterate over it to print all of them to show you that the declaration is at least valid, is what you think it is. Then I call a function called addEnumConstant, which I will show you in a moment. And then I iterate over the same object, over the same enum again, to show you that it now has an extra constant. And if I run this, you can see that during the second run, it now contains an extra suit. So what I did here was a little bit more complicated than the previous one, but not by much. Basically, what I do is I create a new instance of the enum again. This time I give it a new name, a name that doesn't exist yet, in this case the trumps. I give it an ordinal that is one more than the last one. And then the most code that you see here is to trick Java into thinking that the enum is actually in there. So every enum class has a values method that you can use to fetch all of the constants of the enum. And it is backed by a variable called $values, and that's the one that we have to change. So what we do is we create a new array, because the $values field is an array. We create a new one, we copy over all of the existing constants, and then we add our new one to it. And then we have to do a little nasty trick to update the field, because it's a private field. And we actually have to use reflection on the field object of that field to disable the private flag on it. So that's a little mind game that we have to play, but once you figure that out, it's pretty easy to add a new constant at runtime to an existing enum, which, as we all know, you should never do, right? So I'm going to give this 3 emoji. This one is pretty bad. Also a thumbs up from Trump. OK, so who of you has heard of ByteBuddy? That's a surprising number of hands, given that the creator of ByteBuddy is giving a talk in the other room. Could have gone there. I don't. ByteBuddy, for the people who don't know, is a library that you can use to generate bytecode at runtime. And there's a little companion library to it called ByteBuddy Agent that helps you with creating agents in Java. So who of you know what an agent is? About 10 people, I think, which is more than I expected. An agent is a program that you can attach to a running JVM, another JVM, and then it will execute some code in that JVM. There are many use cases for this, many of which are very legitimate. For example, profilers do this. They attach to a program that's already running, and then they insert some code to do the measurements that it has to do. Also, debuggers are implemented as Java agents. Again, they have to insert some code into a running program to be able to stop it and to inspect what values certain variables have, etc. But I'm not here to tell you about the legitimate use cases of this. So this is a thing that was inspired by something that a former coworker of mine did, where he wanted to unit test some code that called out to system.currentTimeMillis. That's obviously pretty hard to unit test, because the value will always be different every time you run the program, right? He wanted to find a way to be able to mock that call, and he found a way to do that using agents. And how it works is like this. I print out every second the current time millis, and then I travel through time, and suddenly I return a constant. And I've replaced the system.currentTimeMillis method. How does that work? It's actually pretty easy with ByteBuddy. First, I install the agent, which means that I have now installed an agent into the JVM that I am currently running in. And then I use ByteBuddy to redefine the system class, specifically the method named currentTimeMillis, and I intercept it to make it return -1 every time. Then I have to make the class, which means that it translates it into bytecode, and I have to load it so that the system actually picks it up. And that's all you have to do to replace system.currentTime for your entire application, which is pretty cool, right? If you do that in a unit test and you forget to return it to its original state, weird things can happen. And of course, system current time is one example, but you can use this for anything. You can replace basically anything in the JVM that you're running. You can use this for good things like unit testing legacy code, or you can really mess up some stuff here. I'm going to give this 3 emoji. But there's more. In my final trick, I will show you how to do this on a different VM, on a different JVM. So what I have here is a program. This will be the victim. Like the previous one, it will go into an infinite loop, and every second it will print the current time millis. It will also print the process ID of the program, because I'm going to use that in a moment. I also have an attack program. It takes 2 parameters on the command line. It contains, the first parameter is the jar file in which the agent lives. And the second one is the process ID of the JVM that I want to modify. And that's the main method. What it does is the main method just installs the agent on the other JVM. Now there's also the agent main method, which is a special method in Java, just like the main method. It has existed like forever. And once my agent is attached to the target JVM, the agent main method is executed inside the target JVM. And here again, I use ByteBuddy to replace the system.currentTime method. And just to show you that I am consistent, I'm naming my lambdas lambda. OK, so to make this work, I have to have a jar file that contains my attacking code. So I'm going to run Maven here. Clean package. So, again, to prove to you that I'm really running this on Java 11, currently I was using Java 8, and my build says, oh no, this is Java 11 code. So I have to switch to JDK 11. As you can see, this is Java 11 now. I run Maven again. I have to wait a while because Scala and Kotlin are both pretty slow here. But it's successful, and now I have a jar file. So that's very nice. Now I'm going to run the victim in my IDE. I'm going to copy this process ID over here. I'm just going to let it run for a while. And now I'm going to call the attacker through Maven using the exec Java, what's it called in Maven, the target. And I copied in my process ID. And if I now run this, this runs successfully. Nothing really much to see here. But in the target, wait, let's stop this. This comes from the attacker, this line of code. So in the target JVM, it says, let's run some malicious code, and then system.currentTime on that JVM is suddenly changed. And the cool thing is, if you have access to your production servers, if you're on a DevOps team, you can do this in production without ever changing any line of code in your code base. You can just run it from an external program. Isn't that neat? So this was actually my final example. And the first time I gave this talk, this was where my story ended. And then some guy in the audience asked me, Jan, this was surely an awareness session, right? You're going to tell us now how to avoid these kinds of things. And I hadn't thought about that at all. I just wanted to mess with you guys. But he did have a point. So for now, I'm going to give you some advice on how to counter all of these things that I've just shown you. So for the first part, where I was playing with emoji and Unicode, the easiest way to guard against that kind of thing is to use check style or sonar cube. You can add some checks in there that will make sure that the build fails or that your quality checks fail whenever you do things like this. But of course, you have all been paying attention, and you know how to avoid check style and sonar cube. So how do you avoid that? Well, there's two ways. The first one is to use a security manager. Not many people do this, but you can do it. And I'm going to show you that it works by going back to the time traveler. So I've now added the security manager to my code, and if I run this program, I have to wait a little bit. It prints the time a couple of times, and then it fails with an exception. And as you can see, it's an access control exception, which is a subclass of the security exception. So this is a way to avoid this kind of nastiness, these reflection attacks. Unfortunately, if you do that, then Spring will fail and Hibernate will fail. So it's not really that useful. I mean, I guess the security manager is configurable, so maybe you can configure it so that all of the things that you want to use from Spring still work. But if you do that, then there's, again, lots of openings for attacks. So if you're using Spring or any other reflection-heavy framework, you're going to be out of luck. The other thing is you can properly modularize your code. That means you have to upgrade to Java 9, 10, or 11 and add in the illegal access equals deny command line switch and make sure that you run it with that command line switch also in production. That in itself is another great way to mess with your coworkers, because who doesn't want to upgrade to Java 11 right now, right? That's going to be a lot of work. And then also modularize your code. That's going to be fun. So in conclusion, I encourage all of you to try this at home, but maybe not at work, right? And that's it. Are there any questions? Question over there.
You mentioned emojis.
Can you speak up a little bit?
You mentioned emojis in Unicode. Have you tried using the invisible characters?
The question was, I have tried emoji and Unicode. Have I tried missing characters, like the non-breaking space, for example, or the Greek question mark? Of course, I've tried them. I didn't include them in this talk because I mean, IntelliJ will already fail on them, so they're pretty obvious. You can't really hide them if you're using a good IDE, which most people do nowadays. But yeah, if you, it is a good way to mess with your coworkers, that's true. Another question over there? Can you speak up a little bit? They're quite noisy down at the party. Yeah?
What kind of permissions do you have to be able to do that? Do you have to be the same user?
Okay. So the question was, in the last example, I was connecting with an agent to a different JVM. And what kind of provisions do you need in order to make that work? Actually, surprisingly little. The only thing that you need to do is add a little line in the manifest file of the attacking jar file. So not the victim, the attacker has to have that line. And the victim, you don't have to do anything. And Oh, permissions. Oh, sorry. You have to be the same user or not. Honestly, I haven't tried this, but I don't think you have to be. I'm not sure, though. Any other questions? OK, I think that's it. You can find my slides on the GitHub. And have a nice evening.